Hi, this is Mr. Devereaux, and I want to talk about one of the problems that you had yesterday for homework. It is on page 332, number 10, and it says, graph each function by making a table of ordered pairs, determine whether it is linear or nonlinear. And then, so you have one that is y is equal to negative x plus 1. We should be able to see that this is linear just by looking at it. We should be able to see that that one is linear because positive 1 would be our b, our y-intercept, and then it is a negative 1 slope, so it's just going to go like that. You could absolutely make a table for this to determine what each input output is, considering it's a function. But I can also look at it and say, hey, it sure does look like y is equal to mx plus b, which is a linear line. So it's linear. Why is it linear? It's a straight line. Bam. Not a whole lot goes into it. But let's look at number 10. Y is equal to negative 4 divided by x. I'm going to get out a separate piece of paper and I'm going to do what I said I was going to do for the first one, or what you could do for the first one. That's make a table. So I'm going to start with the actual equation, which is y is equal to negative 4 divided by x. All right, so here's my x value. Here's the actual equation of what I do. And then here's the y value. So I've got my input, the function, and then the output. One last thing you could do if you wanted to. You don't have to. I don't always do it, but sometimes it's a smart thing to do. What is my ordered pair going to be afterwards, since we are supposed to graph it? Well, let's start with this. I'm actually going to start with 1, just the number 1. When x is 1, what do I have? I have negative 4 over 1. What is negative 4 over 1? It's just negative 4. That means that my value, my coordinates, or my ordered pair, are going to be 1 and negative 4. All right. What happens when x is 2? Well, negative 4 over a2. Negative 4 over 2 is negative 2. Okay? So I have 2, negative 2 as my ordered pair. See, now well, let's look what happens here. 3, that means I have negative 4 over 3. That means that the output, what is negative 4 over 3? It's negative 1 and 1/3. I don't like dealing with decimals. If you wanted to put it in decimals, go right ahead. It would be negative 1.3 repeat, but that's a little bit more concrete for my mind. And then I have 3 and negative 1 and 1/3. You don't have to do this many, but because this one's tricky, the more that you put in, the better it will be. The more direction you have. So if I had negative 4 over 4, that means I just have a negative 1. So 4, negative 1. I'm noticing something here. If I'm dividing by 4, this number technically is getting larger and larger. See, it's getting closer to 0 the whole time. My y value is getting closer to 0. But watch what happens. I'm going to skip a few, and I know that we're not going to be able to graph these, but that's okay. Because I've got 4 as my numerator, look what happens when I have 8. So I have negative 4 over 8. That is negative 1/2. What about 16? I have negative 4 over 16. I have negative 1/4. The higher this gets, the closer this gets to 0. This will never get to 0. My y will never, ever be at 0. All right, that's interesting. Again, I know that I don't even have the room to graph these right now. I'm going to skip 0 for a second. That's the last one I'm going to do. But let's go with some negative values. Negative 1. That means I have negative 4 over negative 1. Negative 4 over negative 1 is a positive 4. So now I have negative 1 and a positive 4 is a ordered pair. I have negative 2, so that's negative 2 over, here I'll draw a line of demarcation there so you see what's going on. Negative 4 over negative 2 is a positive 2. Negative 2 in positive 2. It's looking like it's just the opposite of these. Makes sense. Negative 4, so I would have negative 4 over negative 4 is a positive 1. So negative 4 and positive 1. Now, look at what we've done so far is I have all of these. 1, 2, 3, 4. I did these as just an example. And then 1, 2, I just skipped it. They're the same. It's the same number. I would have gotten positive 1 1/3 if I did that. Let's look at 0. What happens when x is 0? That means I have negative 4 over 0. Can I have negative 4 over 0? I can't. That's undefined. That's an undefined fraction. It's an undefined slope because let's look at it. I'll do this in blue over here. All of these fractions, what do I always say? Fraction means division. So if I have 0 and negative 4, it means I have 0 divided into negative 4. If I multiply 0 by anything, will it be negative 4? No, it won't. This is not a possibility. 0 is not a possibility. This is undefined. It can never be 0. Let's go back now to the graph that we're supposed to do. Let's take a look at this, and I've got my table just to the side so that I can do this really easy. When x is positive 1, y is negative 4. 1, 2, 3, 4. When x is positive 2, it's a negative 2, so here's a positive 2, and then 1, 2. And then when it was 3, it was 1 1/3. Negative 1 1/3 is there-ish, and then 4 and 1. What this is doing, and if I was to go down to 5, or if I was to go to like a half, now this will never ever touch 0. Just like it'll never touch 0 on that side. So I'm gonna have a curved line here, never touching y as 0 and never touching x as 0. They never happen. Now let's look at the negatives. Negative 1 is a positive 4. 1, 2, 3, 4. When x is negative 1, y is positive 4. When x is negative 2, y is negative 2. 1, 2. When it is negative 1, it is 1 1/3. And when it is negative 4, it is a positive 1. So this is just mirroring. Sure it is. Easy for you to say. These are just reflections, how's that, of each other. Never touching zeros, never touching zeros. Is this linear? Absolutely not. Absolutely not. It is just curving, never touching 0. There you go. Don't forget that a good thing to do is to create a table of values. You create a table of values, and then you're going to see what you can do. You plug in your x, you put in your input, and then you get out your output. This is the one that would have been tricky, finding out 0. All right,